Hello, in this module we will see how to work with R for matched data analysis. In case control study, we do consider cases as a representative of the diseased people, and as a control we do consider as a representative of the general populations. So, in case control study we do compare cases, that is diseased people, with general populations. When we are having disease like diabetes or coronary heart disease, those are very common in population. In those cases we can consider 1:1 cases and control. 1 cases with respect to 1 control is enough where we are having not rare disease. When we are having disease like cancer or disease like genetic disorder, those are very rare in the population. In that case, to get a true representative of the populations, we have to consider 1:2 or 1:3 or till 1:5 control per cases. So, there is a way to handling data for case control study through matching for 1:1 as well as 1:n, and this n may be any value between 1 to 5. Here in this module we will consider one simple example where we can go for matched analysis, and as a statistical tool we will generate the value of odds ratio, and based on the odds ratios, points estimates and confidence interval, we will make the statistical inference about our problem. It is a simple real life problem we will going to use here, suitable for matched analysis. Here we are going to test for association between exposure and disease in match case control study, and after that we will see the statistical inference on match analysis. So, the reference is a little book for R for time series, read the docs.org and latest. So, here we can see the reference on this book. Say between exposure and disease in a match case control study, matching is a 1:1 matchings for case control study, where there is a control individuals who is matched to each persons who has the disease. The matched control individual has the same age, race, sex, etc. as the person who has the disease. Then we look to see whether the control individuals and individual with the disease were exposed to some factor, that is if they smoke or to take certain drugs, etc. Matching addresses the issues of confounding in design stage of a study as opposed to analyze the phase, a means of providing a more efficient stratified analysis rather than a direct means of preventing confounding by increasing precision of estimates. Matching can be done two ways. One is called individual matching, another one is frequency matching. In case of individual matchings, controls are matched to cases on one or more attributes, that is age, gender, smoking status, etc. And after that each cases are control pair then has identical values on the matching factors, requires a more complex analysis than unmatched data, and its analytical complexity required to stratify on data not matched on. Each matched set define its own stratum, can be viewed as single individuals. Another matching is frequency matching, where matched on cell instead of individuals. For example, frequency matching on age and sex. If 20% of cases are 50 to 54 years of old males, then control are selected in such a way that 20% are also belongs to 50 to 54 years old and female. It does not require using a matching analysis because you take a random sample of control in that cell, but you have to wait until cases accumulate before controls are selected. Now we are going to preparing the 2 by 2 table by using the matrix functions, and these matrix functions output is assigned to the my matrix. Here these values are assigned as 21, 9, 2 and 12, where we are putting number of row equals to 2 and by row is equals to 2 is given. So here we are having here for to get the 2 rows, and accordingly the first rows and second rows we are putting the by row equals to 2. Now in the second line we are asking the column names, call names of my matrix as control exposed and control unexposed. So it will give the first column name as the control exposed and second column name as the control unexposed. And thereafter when I are putting row names of my matrix, the first row name will be disease exposed and second row name will be disease unexposed. And the whole my matrix, when you are calling as a print of my matrix, we are getting the table of control exposed and control unexposed, and we are getting the 21 as first cell, 9 in the first row second column cell, and first column and second row cell is coming 2 and 12 is the fourth cell. So that is the first attempt to prepare the 2 by 2 table for any match analysis. The functions cal MH ratio will use to do the Mantel-Hazen odds ratio test for associations between exposure and the disease. So that will give us the matchings output, and this code is obtained from our blog, and this code is like that cal MH ratio, that is as a functions of my matrix, and comma alpha is equal to 0.05 is used to take as a level of significance as 95%, and after that case exposed, control unexposed as assigned in my matrix of 1 and 2, that is in the first row and second column is considered here, and case unexposed and control exposed is again showing that as a my matrix of 2, 1. Now we are assigning the MH ratio as case exposed control unexposed divided by case unexposed control exposed, and we are putting print of paste Mantel-Hazen ratios to get the output. In addition to the point estimates of cal MH ratio, we are also putting this confidence interval of cal MH ratio to get the confidence interval, that is 95% confidence interval. We are assigning as confidence level as 1 minus, to get the 95% confidence interval we are assigning confidence level as 1 minus alpha multiplied with 100, and again the sigma, that is square root of this 1 divided by case exposed control unexposed plus 1 by case unexposed control exposed is used to get the standard deviations of this confidence interval, and the sigma is the standard error for out of our estimates of the log of odds ratios. So it is requested to check these theoretical extensions to get the details about the mathematical formula to calculate the MH ratio. Now we are to compare that the calculated odds ratios confidence interval is less than p value or not. We are generating in normal distributions and assigning as Z for Q norms, where 1 minus alpha by 2 is used. For the lower confidence intervals, it is assigned as MH ratio multiplied with exponential of minus Z multiplied with sigma, and as well as upper value or upper confidence interval assigned as the MH ratio multiplied with exponential of Z multiplied with sigma. So now the results has been assigned to get the print of paste confidence level and with lower value and upper value. Now we will see in my matrix, what's the results coming. Now whenever putting the cal image ratio of my matrix, we are getting the Mantel-Hansel ratio is coming as a 4.5 with confidence intervals 0.97 to 20.82. So it shows that the hypothesis, that is this disease exposure and disease unexposure, like here the control exposed having higher with disease exposure in comparison to control unexposed, those who are having disease unexposed. So that is the interpretation about this output. Now we are going for McNamara test as a tool for match analysis, where McNamara test for my matrix is used, and as a result we are getting that p-value coming 0.07. So obviously we can, it's near to the borderline, the p-value, and the chi-square is 3.27. so we can say these in place of matching there is a slightly significant differences there. However, it's not at all significant, because if you consider this 95% cutoff interval value, then in that case 0.07 is not cannot be considered as a cutoff lower than the cutoff value. But anyway, some tendency is there among disease exposure and control exposure. If you put correct dot equals to false, and then this McNamara correction test is showing that p-value comes to 0.07. So if you see the earlier results, it shows that chi-square test with correction factor, but now if you don't go for chi-square test with continuation correction factors, then it's showing that the p-value is 0.03 and says that the match one is having difference between these two groups. It can be inferred that the changes has so much and are on either side of the traditional 0.05 cutoff of the significance. It will be nice to have an extended version of this test to be clearer about the significance at 0.05 level. So in this model we have seen how to do the McNamara test without any specific library, and as well as here we have used the library exact CI and exact 2 multiplied with 2, and after that we have used the McNamara.exact. Here we have also seen how to prepare the 2 by 2 table, and we use the matrix functions to prepare the 2 by 2 table. Once we prepare the 2 by 2 table, then the statistical inference can be obtained through the odds ratio, and odds ratio gives us the idea about the matching analysis result that we have seen here. In addition to that, we have also mentioned that how to extend these discording pairs with assuming they are following this binomial value, and based on that, from this binomial value we can prepare the odds ratio as p by 1 by p. I think this module is will be useful for match analysis, where we are having possible confounding factor, and controlling this confounding factor will give you these more robust statistical inference through McNamara test. Here in this module we have seen how to work with R for matched analysis, how to generate odds ratio for matched analysis data, and make statistical inference about matched analysis. I hope this model will help you to understand the importance of matched analysis and way to carry out matched analysis through R.